Okay. So, this is actually your what you call that vertically integrated utilities. I mean, you have everything together: generation, transmission and distribution. This was the concept, and IPP is the independent power producer, right. So, the vertical, that is VIU, we call vertical integrated utility, is usually interconnected to other vertical integrated utilities. That means tie lines are shown here, both sides it is shown here. I told you, two area system like that. So, similarly it may be connected with other vertically integrated utility system, this may be connected. So, and this interconnection is almost always at the transmission voltage denoted in the figure 1. So, these are actually high voltage line, right. So, it is at the transmission voltage, but not here, not distribution, only at the transmission, right. So, thus electric power can be bought and sold between vertically integrated utilities along these tie lines, and moreover such interconnection provide greater reliability, right. So, this particular power system that is connected with other tie lines also, suppose other through other power system also, right, through the tie lines, and if others they need power, then they can borrow power or purchase power from here, right, or this particular area or power system can borrow power or purchase power from the other connected your power system. So, right. So, that is why it gives more flexibility and it improves the reliability also. The major change that has happened actually is the emergence of independent power producers that can sell power to VIUs, and these are also shown in figure 1. Independent power producer also connected to vertically integrated utility system, they are private parties actually, they can also sell the power, right, they are private parties, right, and this one, the generation, transmission, distribution, maybe it is owned by government, right. So, but independent power producer also nowadays many private parties are there, they are also generating power, right. So, thus at the square boxes, that means this one at the square boxes, right, in figure 1 denote business entities which can buy and or sell electric power, right. So, this IPP actually they are business entities, they can buy or sell power, right. So, for example, if somebody has his own industries, he can have his own power plant. So, this power maybe he can use for his own industry. In addition to that, excess power he can sell it, right. So, given the present situation, it is generally agreed that the first step in deregulation will be to separate the generation of power from the transmission and distribution. That means you separate it, thus putting all the generation on the same footing as the independent power producer. That means all generation companies, like independent power producer is private, this is private, this generation also you put it in IPP such that it will be a separate entity like private power producer, right. So, this is the concept. Now, if we do so, then what we can tell, this is not a VIU, this is deregulated utility structure. In this case, this generation company we call GENCO, in short we call GENCO. I mean this one actually breaking it same thing, that your concept remains same, but 3 different entities, right, 3 different entities. So, this is generation companies, they are private. Suppose if you want that I should have a power generation company, you may have power generation companies, you can sell your power through transmission line to distribution side. This is transmission company we call Transco, right, and this is distribution company, in short we call DISCO, right. So, GENCO, Transco and DISCO. DISCO means distribution company in short, and transmission company is connected to the tie line. Same is here, this is transmission, it is connected to the tie line, and this all generation everything has been a separate. So, GENCO, suppose one generation company has one generator, here is 2 generator, here 2 generator and 1 generator, so on. Here also some GENCO is there, his one generator may be producing power at high voltage level. So, it connected to Transco transmission company. Another GENCO, it is low voltage level, suppose it is distribution companies like wind, solar may be connected at the distribution side. This is also GENCO, only one generator to the your distribution side. So, these are called, and there are 2 distribution companies. So, this is called DISCO and this is called DISCO, and here it is showing in this diagram only one transmission companies. So, suppose that means generation company will be somebody else, right. This may be one person, this may be another person, this may be another person, so many generation companies. Transmission company may be one or more, right, because power wheeling will take place through a transmission company, and distribution companies may be many. That means this distribution company actually has to buy power from these GENCOs, but at a particular time this GENCO will have bidding, you have to go for bidding. This GENCO will tell that today at this moment right, cost of the power is like this. And distribution companies, they have the freedom, they can buy from either of these GENCOs, or from they can contract with many other GENCOs, not only with one generation companies, maybe with many other generation companies. They have the freedom to purchase power, and this power will come to the transmission companies. So transmission, as it is transmitting power, it will also charge many things, right, tariff charge and something price, that generation company as well as distribution company both have to pay to the transmission company. Some bidding will be there, but we will not discuss about transmission companies here, right. Our objective will be generation companies and distribution companies, and power anyway is coming through the transmission companies, right. So that's why that figure 2 shows the deregulated utility structure, right. In figure 2, GENCOs which will compete, right, in a free market to sell electricity they produce, right. So these generation companies also selling power to the distribution companies, and distribution companies also have the freedom who will give me my cheapest power such that I can buy it. Suppose if you go for marketing, for buying something and going to several shops, and if you see this is the cheapest one, naturally you will buy that, right. Same philosophy here, same philosophy here. Therefore, it can be assumed that the retail customers will continue for some time to buy from the local distribution companies. That is they are your local distribution companies, right. Such distribution companies have been designated as DISCOs. Distribution companies we call DISCOs. The entities that will wheel this power between GENCOs and DISCOs, that is between GENCOs and DISCOs, power has to come through transmission company, right. So that will wheel this power, right, between they have been designated as TRANSCOs, transmission companies we call TRANSCOs, several transmission companies. So we are putting TRANSCOs, GENCOs and DISCOs, right. So although it is conceptually clean to have separate functionalities of the GENCOs, TRANSCOs and DISCOs, right, for that what we need is, in reality this will exist, there will exist companies with combined or partial responsibility. That means you need one fourth party that who will handle this, right, who will handle this. So in that case what will happen, you need a separate entity, another office we call your what you call that your, that is we sometimes we call ISO, right. So in that case what will happen, I will tell you what is ISO. Suppose generation company is giving the bid that this is the my price, distribution companies also by bidding will be there, transmission company may be wheeling this power, for all this bidding will go to your what you call somewhere. So sometimes ISO we call independent system operator, right, this ISO. So in that that means it will be a system that where all this bidding will be given here, we call independent system operator, right. So many of the ancillary services, I mean there are many services, reactive power compensation and many other things. AGC is also one of them, of a vertical integrated utility will have a different role to play and hence have to be modeled differently, right. So among these ancillary services, LFC is the one of them, right. There are many ancillary services, I did not list them, I thought it is irrelevant here because our objective is only this thing, right. So in that case, in the new scenario, a DISCO can contact individually with a GENCO, right. I have a distribution companies, I can contact with a GENCO that if I get cheapest power, right, for power, and this transaction will be made when the under the supervision of ISO. So there will be a separate office or separate entity, right, such that they will handle all sort of things. That means your under this condition things becoming actually, although power generation concept, distribution concept, everything remains same, right, transmission concept remains same, but only thing is that things becoming little bit of competitive, hence little bit of complicated too, right. But traditional versus restructured scenario, right. So as there are several GENCOs and DISCOs in the deregulated structure, a DISCO has the freedom to have a contact with any GENCO for transaction of power. Wherever I will get cheapest power, I have a distribution company, say if I get a cheapest power, then I can find out which GENCO will sell, because I will see everything in terms of money and profit, right. If I say I can make more profit, I am getting cheapest power, so naturally I will your what you call go for that, right. So a DISCO may have a contact with a GENCO in another control area also. That means suppose if you take, suppose you have a distribution companies, transmission companies, and suppose your what you call that generation company, transmission and distribution company, suppose one having in Chennai, right, and another companies may have in Coimbatore, say, right. So the distribution companies is Coimbatore need not buy power from the generation company is Coimbatore, there is no need. If distribution company gets power, cheaper power from Chennai, say, then that distribution company can buy power from the generation companies in Chennai, right. So, this freedom will be there, that is why a DISCO may have a contract with the GENCO in another control area, that is suppose it is many areas. So, he can buy, DISCO can buy power. Such transactions are called bilateral transaction. Naturally, power you are buying from other, so it is a bilateral transaction, right. So, little bit mathematics is there, I will show you, it is very easy to understand, right. All the transactions have to be cleared through your what you call an impartial entity called an independent system operator. ISO, I told you, an independent system operator, right. The ISO has to control a number of so called ancillary services. That ISO's responsibility is much more, and one of which is AGC, right. So, this is independent, that means it will be a separate office, right. They will handle all sort of things. So, that means little ideas you have that your what you call that transmission, distribution and generation companies, right. So, now if you look into that, we call DISCO participation matrix, in short DPM, that is DISCO means distribution companies participation matrix. For your understanding, we have taken a small example. Suppose this is area 1 and this is area 2. In area 1, 2 generation companies are there, it may be more, does not matter. Distribution companies also, it may be more, right, does not matter, more less does not matter, but here we have taken identical number. So, just for the purpose of classroom exercise. Suppose in area 1 there are 2 generation companies, GENCO 1 and GENCO 2, 2 distribution companies, DISCO 1 and DISCO 2, and area 2 also 2 generation companies, GENCO 3 and GENCO 4, and 2 distribution companies, DISCO 3 and DISCO 4, right. So, this is a schematic, this is figure 3. So, schematic of a 2 area system in a restructured power system, and direction of power flow we have taken this direction, it may be other direction also, but say for this direction, right. So, this is connected by tie line, this is the tie line. So, in the restructured environment, right, GENCOs sell power to the various DISCOs at competitive prices. I mean, these are the distribution companies. If you get cheapest power, you can buy from GENCO 1 or GENCO 2. Similarly, these distribution companies, if you get cheapest power from area 2, then GENCO 3 and GENCO 4. There is no need that DISCO 1 and DISCO 2, distribution company 1 and distribution company 2 will buy power from GENCO 1 and GENCO 2 from its own area. No, there is no hard and fast rule. If you get cheapest power, it can contact with this GENCO 3 and GENCO 4. I told you, if one is in Chennai, another is Coimbatore, right, like that. So, here also in area 2, DISCO 3 and DISCO 4, right. Suppose if generation companies, if it can buy power from GENCOs, it will be GENCO 1 and GENCO 2, right. Instead of buying power GENCO 3 and GENCO 4, if power is not cheap. So, that means that various DISCOs are at competitive prices. Thus, the DISCOs have the liberty to choose the GENCOs for contract, right. Another thing is that because of this contract and buying selling power, GENCOs will have lot of responsibility to supply power to the distribution companies, because they have the contract. That means more responsible, your GENCOs will be very much responsible for generating that power, such that distribution companies can buy that power whatever contract they have with these GENCOs, right. So, therefore, they may or may not have controls with the GENCOs in their own area, I told you. This makes various combination of GENCO DISCO control possible, contract possible in practice, right. So, what we do in that way, we can define one matrix called DISCO participation matrix, that is DPM is given below, DISCO participation matrix. Just here to understand, right, very simple it is, I understand. First thing is, this is nothing is here, it is blank, this side is GENCOs, this column. Suppose here you have that your 4 generation companies and 4 distribution companies we have taken, that is why in matrix will be like that, but no hard and fast rule. You have n number of DISCOs, m number of GENCOs, here you have p number of DISCOs, q number of GENCOs, something like that, it can be anything. So, we have 4 generation companies, 4 distribution companies. So, this column we are keeping GENCO 1, GENCO 2, GENCO 3 and GENCO 4, and distribution companies DISCO 1, DISCO 2, DISCO 3 and DISCO 4, right. Now, the CPF actually it is called contract participation factor. The term CPF we call contract participation factor. The way we denote the matrix, we putting in like matrix element CPF 11, CPF 12, CPF 13, CPF 14, CPF 21, CPF 22, CPF 23, CPF 24, CPF 31, CPF 32, CPF 33, CPF 34, and CPF 41, CPF 42, CPF 43, CPF 44. No need that this matrix will be 4 into 4, it can be anything. It depends on the number of GENCOs and DISCOs in each area, right. So, these are called contact participation factor. Before moving that, for example, suppose DISCO 1 total power demand, say it needs 10 megawatt, right, it 10 megawatt. So, it may have contact with GENCO 1, GENCO 2, GENCO 3 and GENCO 4. It may not have contact with some GENCOs also, right. Suppose if I assume DISCO 1 has contact with GENCO 1, GENCO 2 and GENCO 4, suppose it needs 10 megawatt, later I will give an example. Suppose it total needs 10 megawatt, right, and suppose if he takes from GENCO 1, suppose total to DISCO 1, that is distribution company 1, is total load demand is 10 megawatt at particular hour, it needs power. Suppose it has contact with GENCO 1, right, GENCO 1, suppose it has contact say 2 megawatt with GENCO 1, then with GENCO 2, right, suppose it has 3 megawatt, right, GENCO 3, it may be 0 also, does not matter, right, it may be 0 also. Suppose GENCO 3 0 megawatt and GENCO 4, suppose it has 5 megawatt, the total is 10 megawatt, right. Then this contact participation factor, this CPF 11, CPF 21, because DISCO has contact with GENCO 1, GENCO 2, GENCO 3, GENCO 4, that means your what you call that CPF, that is contact participation factor 11, I mean this one, it has contact with GENCO 1 2 megawatt, that means it will be 2 by 10 is equal to 0.2, CPF 1, it is always less than equal to 1. Then CPF this 2 1, because DISCO 1 has contact with GENCO 2, so CPF 2 1, this way you have to understand, CPF 2 1, it has 3 megawatt contact, 3 megawatt, so it will be 3 by 10, that is equal to 0.3, right. Similarly, GENCO 3, that means CPF 3 1, it has 0 megawatt contact, that means CPF 3 1 is 0 by 10, that is 0.0, right. And last one, CPF 41 with GENCO 4, it has 5 megawatt contact, 5 megawatt contact. So, CPF your what you call 41, CPF 41 will be your 5 divided by 10, because 5 megawatt, but total DISCOs is 10 megawatt load, total is your what you call, this one is 10 megawatt, total is 10 megawatt. So, that means it is 0.5, right. That means column wise CPF 11, CPF 21, CPF 31, CPF 41, if you add, it has to be 1, that be column wise summation, that CPF 11 plus CPF 21 plus CPF 31 plus CPF 41, CPF 11 is 0.2, CPF 21 is 0.3, CPF 31 is 0.0 and CPF 41 is 5. So, total is 1.0, right. That means this column wise, that this I just told you that column wise is all the summation, here has to be 1, here also has to be 1, column wise summation, here has to be 1, here has to be 1, because DISCO 2 also may have contact with this, DISCO 3 also may have contact with this, DISCO 4 also may have contact with this. That means idea is that whenever this DISCO demands 10 megawatt, I told you, suppose this DISCO 1 demand 10 megawatt, right. So, from GENCO 1 it has contact 2 megawatt, GENCO, but it is at the same time, remember at the same time, maybe at the watch in front of me it is showing 12:40 p.m. So, at this moment, right, suppose this DISCO needs 10 megawatt, then GENCO 1 is 2 megawatt, GENCO 2 needs 3 megawatt, GENCO 3 it has no contact, so 0 megawatt, that means DISCO 1 has no contact with GENCO 3 and with GENCO 4 it is 5 megawatt. So, total is 10, so divide all this thing by 10, so you will get the fraction and total should be column wise, it should be 1, right, column wise it should be 1. So, that is why this is called actually DISCO participation matrix. This is a simple thing, I think you have understood this, it is a simple thing. Similarly, DISCO 2 may have also some contact, DISCO 3, but this column summation should be always 1. Just one I showed you, another one is there here, right. This is for your understanding, right. So, each entry in equation 1, now after I have explained everything, now look, each entry in equation 1 can be thought of as a fraction of the total load contracted by the DISCO, right. If we put that fraction means this 0.2, 0.3, here it is 0 and 0.5, these are the fraction, right, fraction of the total demand by DISCO 1. That means DISCO need is 20 or 10 megawatt, this 0.2 in 10 means it is 2 megawatt, right. So, the entry in equation 1 can be thought of as a fraction of a total load contacted by a disco, that is the column 1, right. This one I told you column wise summation will be always unity. This is the column 1, this is the column 1, right, toward GENCO, right, and it is toward a GENCO, it is row, right, your this thing, the GENCO 1 2 3 4, this row like this, right. Thus the ijth entry correspond to the fraction of the total load power contacted by disco j from a GENCO I, right. So this is we will see for the tie line power how things are like this, right. So I have here it is written in words, but there I have explained how things are, right. Even if you do not read it also does not matter, whatever I have explained the meaning is same here, right. The sum of all the entries in the column in a matrix is unity. Just I told you that column wise if you sum CPF 1 1, CPF 2 1, CPF 3 1 plus CPF 4 1, it has to be 1, right. So that means disco participation matrix, the DPM shows the participation of a disco, that is participation of a distribution companies in a contract with a GENCO, and hence the disco, hence it is called the disco participation matrix, that is its name, right. Now in equation 1 CPF ij refers to, I told you, contract participation factor, here it is mentioned the contract participation factor, it is in general it is CPF ij, right. Now again for the purpose of explanation again, suppose now disco 2 demands 0.1 per unit megawatt, I have now made it per unit, previous one I showed 10 megawatt, now it is a 0 per unit megawatt power, that is disco 2 demands, right. That means this matrix you come here, right, this matrix you come here, suppose disco 1 I told you in the real unit 10 megawatt, it is showing in per unit does not matter. So disco 2 it suppose it has a your what you call your demands 0.1 per unit megawatt power, and your 0.02 per unit megawatt demanded from GENCO 1, that is disco 2 demand GENCO 1, that is your 0.02 per unit megawatt power. Similarly disco 2 from GENCO 2 actually demands 0.035 per unit megawatt from GENCO 2, right. Similarly disco 2 demands from GENCO 3 0.025 per unit megawatt, and similarly this disco 2 it demands from GENCO 4 0.02 per unit megawatt power, that is the real unit, this is per unit. Then your CPF 12 will be 0.02 by 0.1, CPF 22 will be 0.35 by 0.1, CPF your this thing 32 will be 0.025 by your 0.1, and CPF 42 will be 0.02 by your what you call by 0.1. So you will get the fraction of it, and all summation column summation will be 1, right. So that means your the column 2 entities your entries in equation 1 CPF 12 will be 0.02 by 0.1 0.2, CPF 22 will be 0.035 by 0.1 it will be 0.35, CPF 32 will be 0.025 by 0.1 it will be 0.25, and CPF 42 will be 0.02 by 0.1. Previously I took a real unit and here it is given per unit, meaning is same, 0.2. So if you add all it will be 1, 0.2 plus 0.35 plus 0.25 plus 0.2, it is 1. So column wise it has to be your 1, column wise 1. So in general sigma your I in general for some I CPij will be 1.0, right. If j you vary 1 to whatever in whatever your number of distribution companies are there, your generation companies are there, right. So that is your summation should be 1, this is marked as equation 2, right. Therefore this if you look at this diagram, this block diagram, that tie line power flow which you are flowing, right. This is your vertically integrated one, and just hold on, this not this one, just hold on, this one, right, this one. So if you look into that, then what will be the your what you call that tie line power flow, how things will come. So mathematically I will not put, I will put something, but for your understanding what I will do, I will make the things much simpler, right. Now suppose I will assume the power is flowing in this direction, right. So if it is positive this direction, if it is negative one, then it will be automatically in other direction. So this is area 1, this is area 2, right. Now what is the scheduled power flowing your from 1 to 2, right, from 1 to 2. So this is area 1, this is area 2, right. So if you have thing, you can write that this is your area 1, I make it short, this is area 1 and this is area 2, right, and direction we have taken that from this one to this one. So, in that case what will happen, that it will be that what is the power flowing from area 1 to area 2 in this direction, that means demand of discos in area 2, right, from the GENCOs in area 1, because if disco purchase power from this GENCO 1, so disco's demand from this one will flow in this direction, right, because disco wants to buy power from this GENCO, that means power will be flowing in this direction, minus these discos if you have a contract buying power from this, so minus this discos buying power from this one, because it has to be minus, because it is basically your from 2 to 1 it is coming. So, I have to make it I have to minus it, that is I have to subtract. That is why demand of discos in area 2 from GENCOs in area 1, because it is your 1 to 2 this direction we have taken, power is flowing. So, demand of discos in area 2, that means this is your area 2 from GENCO 1, then only power will flow in this direction. So, minus demand of discos in area 1 from GENCOs in area 2. So, minus demand of discos in area 1 from GENCOs in area 2, right. So, in that case what will happen, this equation I have written, I is equal to 1 to 2, j is equal to 3 to 4, CPF ij delta PLJ minus I is equal to 3 to 4 and j is equal to 1 to 2, CPF ij delta PLJ, this is equation 3. Here this I have written for sake of mathematics, but don't better you don't try to, because this can be made as in terms of GENCO and DISCO, all this your what we call this number, right, general one. I do not want to generalize one, just see how things are. Look at this equation, right. So, delta P tie 1 to schedule, right. So, first thing is that DISCO this thing buying power from this GENCOs. Now, if you go to the DISCO participation matrix here, right, each DISCO is having power demand delta PL1, this DISCO 1, DISCO 2 delta PL2, this is delta PL3 and this is delta PL4, right. Therefore, this DISCOs in area your 2, right, this DISCOs in area 2 buying power from GENCOs in area 1. So, DISCOs in area 2 is DISCO 3 and DISCO 4 and buying power from GENCO 1 and GENCO 2. That means, CPF 13 into your delta your what you call PL3, right. So, this is actually 1 to 2 schedule. See, so generally that your what you call this just hold on. So, delta P tie 1 to schedule will be CPF 13 delta PL3 plus CPF 14 delta PL4. So, this is actually your CPF 13, right, into your this is that your the DISCO 3 may have contact with this one CPF 13 into delta PL3, because this is a fraction and this DISCO's demand is delta PL3. So, but this DISCO 3 DISCO 4 buying power from GENCO 1 GENCO 2, because GENCO 1 GENCO 2 is area 1 and DISCO 3 DISCO 4 is in your area 2. So, it is CPF 13 into your delta P3 PL3 this DISCO's thing. So, CPF 13 delta PL3 plus this DISCO 4 also in area 2. So, CPF 14, right, into delta PL4, because CPF 13 CPF 14 DISCO 3 DISCO 4 has contact with GENCO in area 1 GENCO 1 in area 1. That is why it is CPF 14 into delta PL4. Similarly, this your CPF 23 DISCO 3 it has contact in area 2 GENCO, that is area 1 GENCO 2. So, CPF 23 into your delta PL3, right, this one plus CPF 24 this CPF 24 into delta PL4, because delta PL1 delta PL2 delta PL3 delta PL4 it is the power demand of DISCO 1 DISCO 2 DISCO 3 and DISCO 4, right. So, here it is also CPF 24 into delta PL4. So, this part that DISCO's contact that area this thing the area 2 DISCOs whatever they have contact with GENCOs, this thing is complex, the plus part is complex. Now, minus means demand of DISCOs in area 1 from GENCOs in area 2. In area 1 DISCO 1 DISCO 2 is there, right. So, in that case your now minus CPF 31 delta PL1, right. If you come to CPF 31, this is CPF 31, right, DISCO 1 it demand is delta PL1 and it is GENCO 3 GENCO 4 is in area 2. So, CPF 31 into your delta PL1 then CPF 32 into your delta P or what you call delta PL2. So, CPF 32 into delta PL2 plus now you will come to your what you call that DISCO 2 it is CPF 41 into delta PL1. So, in that case it is CPF 41, right, into delta PL1 then here it is CPF42 into delta PL2, because the CPF41, the disco 2 has contact with GENCO 4. See, disco 2, when this kind of CPF4 to the fraction of power, that disco, it has contact with GENCO 4. So, plus CPF41 delta PL1 plus CPF42 into delta PL2. This is equation 4. This is actually schedule power, this thing, that how much actually direct power is flowing from your what you call from GENCO from area 1 to area 2. It may become negative also. It may become negative also. Negative means power is flowing from this to that. How much they have contact accordingly, right? So, the delta PR may be positive, may be negative, does not matter, right? It may become negative also. So, rather than this equation, this understanding is required, right? I mean when we will go through this, then please just your what you call, just if you have any doubt, you can put the question in forum. Further we can tell you without this thing, right? So, one little small thing is there for AGC deregulation, that will be taken care, right? And after that little bit unit commitment will be covered, but in very brief, because very difficult to solve in the classroom, but some concept will be given that what is unit commitment and how one can proceed, right? So, thank you very much.